Definition of quantum supremacy. Okay, let's talk about quantum supremacy. Imagine you have two types of super smart computers, one that we usually use, and another really special one called a quantum computer. Quantum supremacy is when this quantum computer can solve a certain type of math problem much faster than the very best regular computers we have today. To understand this, let's think about a race. Imagine you have the fastest runner in one team and the fastest swimmer in another team. If they race on land, the runner will win for sure. But if they race in water, the swimmer will win easily. This is like quantum supremacy. The quantum computer is like the super swimmer, and the regular computer is like the fast runner, but for a different type of math problem. This special math problem is like a puzzle that regular computers find really hard to solve quickly. It's designed in a way that makes quantum computers really good at it. So, when a quantum computer solves it, it's like saying, "Hey, look, I can do this way faster than any regular computer can." Achieving quantum supremacy is a big deal because it shows that quantum computers have superpowers for certain kinds of problems. It's a bit like discovering a new type of vehicle that can zoom through certain terrains much faster than any existing ones. Experimental demonstration. Alright, so now we're talking about how scientists actually showed that a quantum computer can do this super fast math. Imagine there's a special quantum computer called Sycamore, built by a big company called Google. They set up a challenge for Sycamore to solve a particular tricky math problem. This math problem is like a puzzle, but it's really tough for regular computers. It's so tough that if you give it to the best regular supercomputers we have today, they would take thousands of years to solve it. But Sycamore, the quantum computer, can do it much faster. In an experiment, Sycamore finished solving this problem in just about 200 seconds. That's like saying it ran a race and finished super quickly. To put it in perspective, even the mightiest regular supercomputers would take thousands of years to finish this race. It's kind of like if there's a race where regular runners would take years to finish, but Sycamore, the quantum computer, zoomed past the finish line in just a couple of minutes. So, this experiment was a big deal. It showed that quantum computers are like math superstars for this specific type of problem. It's like saying, "Look, we've got this special computer that can do certain math problems in the blink of an eye." This experiment proved that quantum computers have a unique advantage for certain kinds of really tough math. Sampling problem and Sycamore. Now, let's talk about this special math problem that Sycamore, the quantum computer, solved. This problem is called a random quantum circuit sampling problem. It's a bit like a game that quantum computers are really good at playing. In this game, you create a set of rules for how particles should move around and interact in a quantum world. Then, you let the quantum computer follow these rules. It's like telling the computer, "Okay, go ahead and play this game according to these instructions." Once Sycamore plays the game, it gives you an answer. This answer is like the score of the game. But here's the tricky part. Figuring out this score is super tough for regular computers. It's like trying to solve a puzzle with a gazillion pieces. The reason Sycamore is so good at this game is because it uses tiny bits called qubits to do many things at once, thanks to some really weird and cool properties of quantum physics. It's like having a super multitasking brain. When Sycamore played this game in the experiment, it gave an answer really fast. The regular supercomputers would struggle for thousands of years to get this answer. But Sycamore did it in just about 200 seconds. So, this experiment showed that for this specific game, Sycamore, the quantum computer, is like a math genius. It can solve problems that would take regular computers thousands of years in just a few minutes. It's like discovering a super player who excels in a particular game that's extremely hard for everyone else. Practical implications of quantum supremacy. Now that we know Sycamore, the quantum computer, can solve this special math problem super fast, what does it mean for us? Well, it's like having a super fast car that can get you to your destination much quicker than any other car. Let's see how this can be useful. First, think about secret codes and passwords. Regular computers use complex math to make these codes, but quantum computers like Sycamore can crack them much faster. This means they can help us keep our online information safe and secure. Next, let's talk about really tough problems, like figuring out the best way to plan routes for deliveries or finding new medicines. These tasks involve lots of options and can take a long time for regular computers. But with Sycamore's speedy math skills, it can give us answers much quicker. It's like having a super smart helper for these big tasks. Also, scientists are curious about how things work in the tiniest particles and molecules. Quantum computers can simulate and understand these tiny worlds much better than regular ones. It's like having a special microscope that can see things in more detail. So, quantum supremacy with Sycamore opens up exciting possibilities. It's like having a tool that can help us solve some really big and important problems in science, technology, and even everyday life. It's like finding a super tool that makes tough jobs much easier. Controversy and debate around quantum supremacy. Now that we've seen how Sycamore, the quantum computer, can do certain math problems much faster than regular computers, let's talk about what this discovery sparked in the world of science. Imagine a big soccer game where there are referees, players, and fans. When Google, the company that built Sycamore, announced their achievement, it was a bit like blowing the referee's whistle at the game. Everyone stopped and started discussing what this meant for the match. Some scientists said, "Wow, this is amazing. It's a big leap in the world of computers, and it shows that quantum computers have real power." They were excited about the new possibilities that Sycamore and other quantum computers could bring. But there were also people who said, "Hold on a minute. Is this achievement really that important?" They argued that the specific math problem Sycamore solved might not be all that practical or useful in our everyday lives. It's a bit like having a great soccer player who scored a goal, but some people questioned whether it was in a crucial part of the game. Another debate was about regular computers. Some scientists wondered if we could make our regular computers even better at solving this particular problem. It's like saying, can we train our soccer players to be faster and score more goals? So, quantum supremacy didn't just bring applause, it also brought a lot of questions and discussions. It's like a hot topic in the soccer world, with some people cheering and others analyzing if the game has changed for good. In the end, though, it's clear that this discovery is a significant step in the journey of quantum computers. It might not have settled all debates, but it definitely made people take notice and think about the future of computing.